Refresh it. Okay. Now it looks fun. I really like to make a game with this. Hello to my favorite people on the planet. This is the second part of heaps.io tutorial series. In the last part we went over the basics. We installed the heaps.io hacks and everything we needed, and we just did a hello world application. In this video, however, we're gonna talk about the basic 2D stuff in heaps, and we're gonna learn about them, and we're gonna just use them in one example to really get savvy about it. I'm not sure if I'm using the word savvy right here, but it's a new word that I learned recently and I wanted to just use it. And whatever, let's get back to the business here. The first thing you need to know about 2D stuff in heaps is pixels. Pixels is the sum of pixel. So it's a lot of pixels in one array, a 2D array. So an m by n array full of pixels. Okay, let's pretend this is an array and these are pixels, and in each one of these pieces there is a color. So that's red, that's green, that's black, red, or whatever. There's a color in every one of these things, and it gets stored in our RAM, in our computer memory, and we can easily just modify this. We can just turn it to red or whatever. We can easily modify each pixel in the pixels. Okay, so that's for pixels. And we have a texture. A texture is a pixel that is now in GPU. So when we want to do graphical stuffs, we use GPU because it's faster. And when we move the pixels from RAM to GPU, we cannot easily modify and access it anymore. So when we turn pixels to texture, it's not easy to modify anymore. We have to modify them as pixels and then turn them to texture to be able to render them using our GPU. Okay, the next thing that we're gonna talk about is a tile. A tile is a part of a texture. So let's say we have a texture. Let's say all of these shapes is one texture. It's an animation cycle in which, let's pretend the character is trying to punch something, and if all of this is one texture, we can divide it into tiles. So we can say this is tile number 0, this is tile number 1, and we can play these tiles one by one in an animation. An animation is an array of tiles, and a tile is a part of a texture, and it also has a pivot. So yeah, that there's the tiles and animation. So you know what are tiles and you know what are animations right now, and you know that tiles have pivots. That's very good. The next thing that we're gonna know about is an object. An object is something that has transform. It has X, Y for the position. It has rotation, and yeah, these kind of stuff. The stuff that helps us to determine the position of something in the scene. So the next thing that we're gonna talk about is scene. Yeah, the scene contains a lot of objects, so it's an array of objects, and when it's active, when a scene is active, the objects in the scene are active too. And also, objects can be parents. So when an object is a parent of some other object, when we change the position or rotation of that object that is parent, it changes the rotation and the position of the child relatively. Another good thing to know is that a scene, an active scene, is responsible for input like touch or mouse click or keyboard events. Okay, the last thing that we're going to talk about today is bitmap. So bitmap is an object which displays a tile. Object plus tile is equal to bitmap. So knowing the theory of this, we should dive into an example to just really understand it by heart. So let me open up Visual Studio Code and build on the project that we made, the Hello project that we made in the last episode. Okay, this is how we left our last project from the last episode. It's just a simple Hello World application that we wrote. So what we're gonna do today is, first of all, we're gonna define a variable. And variables in hacks are defined in a weird way. We use the keyword variable. We specify a name like BMP, and then we specify the type. And the type here is h2d.bitmap. We want to create a bitmap to display some object, a 2D array of pixels that is a texture, that is a tile, as a bitmap. Knowing the theory from before, you should understand what I said. But if you don't understand what I just said, please make sure to leave a comment down below and ask any questions. Okay, I'm gonna delete this stuff from the last time, and I'm gonna add another function in addition to the initialization function of our main class, and that's override function update. But what is update? Okay, let's talk about update. The initialization function is a function that gets called whenever the main class is initialized. Like this, when we say new main, it calls our initialization function first to initialize our main class of our application. And the update function gets called every frame, and it actually receives an input. We call the input delta time. You can choose whatever name you want, but the type has to be a float. So this is just like this. Specify the name and specify the type. So we call dt or delta time, and the type is float. But what is dt or delta time? The dt or delta time is the time difference between the last time the update was called and now. In other words, delta time is the delta time between two frames, and it has a lot of useful applications that we're going to talk about later. What I'm going to do here is, first of all, I'm going to just first comment things out and then implement them. First of all, we're going to create a red texture, and let me use the plus sign, plus create a 100 by 100 tile from it. Then after that, we want to create a bitmap object and add it to the default 2D scene. And you should remember from the last episode that the default 2D scene is S2D. And after that, we want to modify the display position of the bitmap object that we created. Okay, we're gonna go over the implementation of each of these parts. For the first part, to make a red texture and create a tile from it, we simply define a variable called tile, and we set it equal to h2d. It's just heaps 2D library. h2d dot tile. We want a tile. We want a tile from a color, and we want to specify a color here with hash code. So this is color red. Hello guys, really quick note. You should use a small x instead of capital X. I used capital X by mistake, so make sure to use small x. And after that, we tell it the size of our tile that we want to extract from the texture. So we want 100 by 100 tile. So it's width here, and it's height. I don't know if the T is pronounced or not, but whatever. The height, or the height of our tile. Sorry for going into the rabbit holes from time to time. It's just me. Okay. The next step is to create a bitmap object and add it to the default 2D scene. So this is how we create a bitmap object. We already defined the variable for our bitmap with the type bitmap. So we call BMP, and we set it equal to new. We want a new bitmap. So new h2d. Access the library dot bitmap. So this receives two inputs. First is the tile that we want our bitmap to be built from, and second is the scene that we want our bitmap object to be in. We want the s2d, which is the default scene here. And after that, we want to modify the position by calling bmp.x is equal to s2d.width times half. So we want to place it in the middle of the screen, right? bmp.y is equal to s2d.height, or height, sorry, times half. So yeah, that should work. Now if we compile our code and we run it in Chrome, it should show us 100 by 100 square that is red in the middle of our screen. Okay, our code got compiled, and this is the result: a red square in the middle of the screen. You may say, this is not the middle of the screen, you dumb fuck. Are you fucking stupid? What are these tutorials that you're making and uploading? Like, are you even joking, or what the fuck is the problem with you? And the answer to that is yes, this is the middle of the screen, but the pivot of the tile is on the upper left side of it by default. So this is the middle of the screen, but the pivoting is not right. So we have to set the pivot of this square in the middle of it to make everything work. So to do that, the pivot is a property of a tile. So we have to modify our tile. So we call tile dot dx, and we set it to tile dot width divided by 2, not 5, 2, and tile dot dy, which is the y pivot of it. We set it to tile dot height divided by 2, and we have to add a minus before each one of these guys, because this is actually not the pivot, it's the delta x of the tile when we want to render it. So to really use it as a pivot, we have to add this minus thing behind it to use this delta x and delta y as pivots. Now if you save this and compile it, of course, and then go to our browser and refresh it. The pivoting is right, and the square should be in the middle of the screen. Okay, now that we know all of these stuff that we talked about and did, it's time to try our hands on this update function that is a little bit in some Mr. Fog. Let's demystify it. Like, I don't know the meaning of these words I'm using. I hope they're correct. I'm sorry if they're not, but English is not my native language, obviously. I'm just trying my best. I'm sorry, guys. I'm sorry. Okay, let's get to update. So, to demonstrate the functionality of this update thing, let's make our our square thing here bounce, like go down, come up, go down, come up. To do that, we need a bunch of variables that I'm gonna define up here. First of all, we need a velocity, which is of type float. Then we need gravity, which is also of type float. That should do the job for now. In here, first of all, let's just drop the square for the basic part of it. What we want to do is to change the y position of our BMP object. So we go ahead and say bmp.y plus equal to 1. So first of all, let's see what happens and then we'll talk about it. Okay, this is what is happening. It goes 1 pixel down in each frame. So 1 pixel down in each frame. First of all, it's very, very slow. So what we want to do is to define a chunk size. So let's say every 100 pixels is 1 meter or 1 unit in our game. So we say var, we define another variable called chunk size. This is where things get really interesting, man. We define chunk size of type float, and we set it equal to 100. Set gravity equal to 9.8, and we set velocity equal to 0. And every time we want to change x by any value, we just we multiply it by our chunk size, just like that. Now if we compile our code and go to our browser, it falls pretty much faster, but it falls 1 unit per frame. What if we want to move it 1 frame per second? What do we do then? Can you guess the answer? The answer lies around here. Okay, if you can't guess the answer, you're a game developer. But if you don't know about it, I'm just gonna explain it to you real quick. So don't worry. Delta time is a difference from the last frame, the time difference between the last frame and this frame. So dt is equal t1 minus t0, and it's not exactly 1 second. It's more of a fraction of a second, like let's say half of a second. So if it's half of a second and we want to move our box 1 unit per second, we have to move it half of a unit per frame. So that is how we use delta time. We just say bmp.y plus equal to 1 times chunk size times delta time. It's this easy. Now if we compile our code and go to our browser and refresh it, it falls 100 pixels per second, or 1 chunk per second. What we want to do here now is to apply the gravity. So we don't want to move it 1 frame per second, one chunk size per second, but velocity chunk size per second. We want to apply the speed to the position, and we want to apply the gravity to the speed. So velocity is plus equal by gravity times chunk size times dt. Okay, we can drop the chunk size here. Let me drop the chunk size over here. Okay, compile. I always forget to compile. Refresh. Okay, it has a gravity, so it doesn't really fall dully. I don't know if that's even a word. I'm sorry, what kind of tutorial is this? Okay, it has gravity, so if you want it to bounce when it arrives at the bottom, we need to. Can you go ahead and code it for yourself as an exercise, and then come back and see how I do it? If you do that, I promise you're gonna learn better. So pause the video now, go try and come back. I'm gonna just assume you did that now. Okay, what we want to do here is to check the position of our BMP against the height of our scene. So whenever it arrives at the bottom of the screen, we want to reverse the velocity, like it bounces back. So what we want to do here is to check our Y position of our BMP against the S to D dot height. And if that happens, what we want to do is to reverse the velocity, just like velocity is equal to minus velocity. First of all, let's add to the gravity. It has more excitement to it. Let's make it 20. And then add to the bmp.y bmp.tile.y divided by 2 to make sure whenever the bottom of this tile hits the ground, we reverse the velocity, just like that. If you compile it and refresh our browser, okay, this is much better now. Refresh it. Okay, now it looks fun. I really like to make a game with this. Maybe what is happening here? Oh my god, man, there's some bad bug in here. Okay, I don't know what's happening, but yeah, this is our this is our end product here for this session. And make sure to subscribe to my channel, leave comments down below, and like the video if you liked it. And yeah, this is this is it. I'm gonna upload the new episode tomorrow. I hope you learned things. If you have any questions, ask me, and yeah, you know, all that stuff. And follow me on Twitter. So yeah, see you in the next episode, guys. Have fun.